everybody. This is going to be a tutorial about how to program a top-down game using processing. Processing, in my opinion, is probably the best language to start programming with. Being that it's set up to do graphics, it's quite simple. You can start really simple if you want, and then you can progress into much more advanced things, being that the processing language is actually just a subset of the Java language. So you'll be learning Java, which is, obviously a very good skill to have. And processing has a bunch of examples that you can start out with. So um, probably one of the best ways, in my opinion, is to just go to the examples and processing, open one up, and then start modifying it. Today, what I'm going to do is actually just go ahead and start from scratch. So I got my processing fired up here, and what I want to do is I'll go ahead and save this first so I get the file name and everything worked out. It's going to create a data folder for me, so that's actually what I'm really going after, so I can put my information in, like the sprites that I want to use. So let's see here. Go to processing tutorial. Okay, you can save this wherever and name it whatever you want, but I'm gonna name mine Bird's Eye Tutorial. This is based on a game that I'm actually making called The Bird's Eye, which is, it's kind of like a corny game, but I created it with the intention to make a video series on how to program and processing. So yeah, you can actually go and download the game too if you want to check out my Patreon page, and if you can donate some money, that'd be great. Then I can finish the game and also produce more tutorials. And anyways, you can go ahead and download this if you want, and you'll be able to actually access all the code from the pretty much finished version of the demo that I have so far, and you'll be able to see everything, how it all fits together. You'll be able to get all the sprites and everything that I used in the game, so it'll be easy. But for now, I'm just going to copy a few of the sprites that I had from the original. Actually, I'm sorry, this didn't create a data folder, but if you see the way that processing works is that the file name of the file needs to match the name of the folder that it's within. As you can see, I saved it into this folder called Bird's Eye Game Tutorial, and it created another folder inside called Bird's Eye Tutorial with the same name as the file. And so you see the file name that I created in here, .pde. This is the processing data files. So what I actually want to do is I'm going to create a new folder in here called data. It's everything that it accesses for the sprites, any of the data that it uses, it'll access it in data, any of the sprites, any of the audio, etc. So anyways, what we want to start out with are the two basic processing methods here, which are setup and also draw. So the way that processing works is that it goes into it starts out, it calls setup once at the very beginning of the program, and then it calls draw over and over again, and it draws everything, and nothing will actually display on your monitor, on your screen, until it hits the end of this draw method here. So that's how you got to think about it. I'll get more into detail into like the dynamics of that and how it works, how it affects your game programming later on here. But essentially what you want to do is do all the initial setup inside the setup function. And while I'm going through here, actually, I'm going to go ahead and I'll be copying some code from the original one here that I created, just because I can't remember how I did everything. So I'm going to just put that window to the side there and go ahead and look in this one. So So really the first thing that you're going to need to do in setup is to set the size. Um, so I want to make a window that's 800 by 800, and I can actually go ahead and run this already. This is one of the other great things about processing, is that all you do is you download processing, you just open it up and then type in some code, and then you just hit this run button and the stop buttons, and it'll work on any computer. It doesn't really matter. You can even download the processing development environments for Android phones, which is really great. So you can program while you're while you're on the go or in a car or a bus or whatever. So yeah, so basically what I did is I just created a window that's these dimensions, 800 by 800. Um, this is what 800 by 800 looks like in a processing window. So this is 800 pixels, by the way, 800 pixels by 800 pixels. So what that does is actually creates it sets two variables called width and height, which you don't need to worry about what I'm doing over here. It actually it'll save the 800 and 800 in those two variables. Those will be the screen and width and the screen height. And then what I need to do is what I'm going to start out with doing is creating the basic tile map and display some tiles. So what I'm going to do first, actually, I'm just going to go ahead and copy in the tiles that I used for the tile map. So I have a number here that I used. Grass, copied that one. And again, I'm putting this in the. Just find the right folder. Okay, this is the folder that I was using. So I'm going to go ahead and paste that one in there. So I have a number of files for lava. I actually did some animation with that one, which I will show you how to do the animation probably in the next tutorial. For now, I'm just going to use one of those lava files, not all of them. Okay, so these are all the tiles that I created. I just literally created these by hand on my Android device, so they're really corny and basic looking, but you can see, just really simple tiles. I mean, this is just intended to be tutorial, so whatever. So anyways, actually what I'm going to do, I'm going to delete this one called C because I have C1, C2, C3. These are all the same. So there you go. That's pretty much what I got here. So I'm going to close these. So really basic map tile set here. And what I'm going to do to start out then is I'm going to go ahead and load the tiles. So what I actually need to do is I need to create some like global variables to store the map tiles, so that the game knows like what it's using. So I'm going to start out with the processing structure. It's a class that's provided by processing, and rather like a data type that's provided by processing called p-image. And I'm going to create an array of the p-images, and I'm going to call this map tiles. And okay, so then we need to do. So this basically just creates the variable map tiles. It creates this reference so that you can call it from anywhere inside of the program. And there's a number of different ways to do this, but I just created a global variable like this inside of my program. It's probably one of the easiest ways to do it. So anyways, once you create the this what is called a reference to an array of p-images, then what you need to do is actually create the you have to actually create the array of p-images inside of memory. So the way you do that in Java which is processing. Processing is Java basically. So the way you do that is that you say new p image array. You have to specify those two brackets there. Or actually, I'm sorry. The way you do it with arrays is that you got to just specify the number of images that you want. So I'm going to start small here and not do the animation. So I'm only going to use one frame of each of these. So you got 1, 2, 3, 4, 5, 6. So 6 images altogether. And then what I'm going to do is I'm actually going to just load each one of them. So really straightforward here. Just start with the first index, and there is this function that processing provides called load image, and that takes the most basic form of it is that it takes a file name. And and by the way, the 0, if you're not familiar with programming, 0 is just the first index of this array, and an array is just a list of items of whatever the type you specify, which is p image. So this is a list of 6 p images, and it starts at index 0. So it goes from 0, 1, 2, 3, 4, 5, which is 6 altogether. So I'm gonna just go ahead and copy this actually a bunch of times, and then I'm gonna fill in blanks. I mean, I got 1, 2, 3, 4, 5, 6. So this is just my quick way of doing this. 3, 4, and 5. So as you see, 1, 2, 3, 4, 5, 6 all together, and it starts with index 0. So it's 0 through 5 are the indexes. And then I'll take the file names here. So you got grass1.png. Let's put it like that. You don't have to specify the file path because it's in the data folder. And level1 PNG. There we go, level1 PNG. Alright, level2 PNG. C1 PNG. And C1 PNG. Alright, great. So I'm going to just go ahead and save this now, what I got. And usually every time that I add some code to something, I'll just go ahead and run it and just make sure that it actually runs, so I didn't have any errors that come up, and it'll display the errors down here, which is the other really nice thing about processing. So let me make this window a little bit bigger here for you guys. And so anyways, so now we got our setup. We just loaded a bunch of images. That's all we did. And now what we want to do, we can just go ahead and actually we can start displaying them, by the way, which is image is the name of the function that processing uses to display an image. And image will actually takes a number of parameters, which is kind of cool. You see down here, it actually will tell you what parameters that it expects to take. So it takes the p image that you want to display in the 2 floats, and floats are there's 2 different data types if you're not familiar. There's an integer, whatever, and then there's float, and then you call that f. So the integer I, this can be like 0, 1, 2, 20, 200, whatever, 2000, whatever. And then this can be like 0, 0.0, 1.0, 1.1, 1.02, 1.03. So the thing about floats that it has decimal places on it. This could be whatever. It can have decimal numbers past the decimal place, past the decimal point here, and then integers cannot have any numbers past the decimal point. So that's the difference between integers and a float. That's all it is. So anyways, what I'm going to do, I'm going to go ahead and display the map tiles sub 0. Map tile that I have in that list at the index 0, which would be the grass.png, and I'll display that at, we'll say 50, 50, whatever. It could be any coordinates here, depending on what, in case I want to do. I'm just showing you. So it displayed that grass here at this coordinate 50, 50. So there's another thing to note about processing is the coordinate system starts up here equal to 0, 0. This point of the very upper left-hand corner is 0, 0, and as you progress towards the right, the x value goes up. So this 50, go 50 over to the right, and then 50 down So as you the y value goes up, it goes down here on the y-axis. The location that you're just drawing will go downwards. So 50 on the y-axis is down here. Negative 50 would be like up here, but you wouldn't be able to see that. So this is 50 here. So anyways, that's just the basics of how you draw stuff with processing. So anyways, what we need to do is since we need to do this in a kind of an organized fashion, we need to create a we want to create a map class. So we'll create a class, call it map, and a good naming convention for classes is to make the names uppercase. These are basically like blueprints. You're actually creating like a data type, like how I use pimage up here to create this list of map tiles. I will use this class name here to create a map, to create an instance of a map, and I'll actually put it up here later. So the classes, they have properties, and then they have methods which they can do. So the properties will be like in this case it'll be a list of indexes into this list of tiles. So basically this is like the palette essentially. Actually what I can do, I can name this map tile palette. It actually makes more sense. So map tile palette, and then what I'll do is I'll actually do a find and replace all. Okay, so I just replaced that name everywhere here with this map tile palette. So it just makes a little bit more sense maybe when you're thinking about how this all fits together. So what I want actually is I want a list of integers, and I want that list so I'll call this actually tiles, because the map has its tiles, and I'm making that just a contiguous list, even though it's going to be like two-dimensional. I'm making that just a contiguous list, and the size will be 50-50. So I'll make this what do you call it? I'll make some variables here or rather some properties for the map that will tell you what its size is in the x and the y direction, and that way it can do computations based on the size and figure out where, in 2 dimensions each tile is, being that this is a 1-dimensional list of the tiles. So this will all come together in a second here. So anyways, all classes have what's called their constructor function. So the map, I'll just start out with a constructor that doesn't take any parameters as input here. So basically it doesn't need any information from the outside world to start itself up. So the constructor just basically, when you create a map, it'll call this automatically, and it'll run this to initialize everything to whatever the values that you want. That's what the intention of these functions are, of the constructor methods rather, I should say. So then I want to set my tiles equal to a new int, and then that will be size x times size y. Since this is again, this is like the the area of a rectangle will be the width times the height. So that's basically what I'm doing, and that'll be the number of tiles that I need. So it's 50 by 50, so the size is 50 times 50 for the the number of tiles that'll actually be inside the map will be 50 times 50. So I think that'll work. Let me actually go ahead and save this again and then run it and see if that works. Okay, yeah, I think that worked. So let's see here. So what I want to do now is I'll say display the map, and this is a method that actually needs to have the return type specified, which is void, which means it's not going to return anything. It just does some stuff in here, and that's it. Let me see here. So what I want to do is I'll create a for loop. So I'll say for int I equals 0, I is less than, and I could just say tiles dot size. This is something about Java that's really nice, that you that if you create an array or just like a list of something this way, then it automatically will give you this function that you can call to get the size of this thing, which it'll be size x times size y, but somewhere else in the code I might not be easy to find where I did this, so I won't. So I just want to use this to reference what the size is. And so the for loop, basically what that'll do is it's going to loop through this tiles array, and I'm going to display each tile where it's supposed to go. Basically, yeah, it starts out with I equals 0. So again, the index of all these lists, they start at 0. That's basically what I'm doing. I'm setting I equals to 0. I'm looping I until it's 1 less than the size, which, as you remember, this was 6, and then the maximum index is 5, which is 1 less than the size. So that's what I'm doing. It's I less than. If I did I less than or equal to size, then it would go all the way up to the size, which is just one too many from in the list. So I want to do loop until I is less than tiles that size, and then I increment I each time that it goes through the loop. So it starts out with this. It calls this only once. It checks this each time before it goes through and executes any code inside of here. And then at the end of executing all the code inside of here, it does this, which increments I. It just says I equals I plus 1. So the first time it'll be 0, then the second time it'll be 1, then the third time it'll be 2, 3, 4, 5, 6. It just counts up I. So what I can do inside of here is oh, I'm sorry. Okay, so what my problem here actually, the arrays in Java, they don't use the size function here. Actually, they use length, which is just a property of the tiles. It is the same thing that I was talking about before. It just gives you the actual length of the array. So for instance, it would return 6 if you ask for the length of the map tile palette. And this will be 50 times 50, whatever that is equal to, is what it will return with this. So anyways, what I want to do now is I'm going to actually go ahead and display it. So the way you display it, if you remember, is the image method that processing provides, and then we will display. What we're actually going to display is the map tile palette at the index of whatever is stored in that tiles array, and I'll show you here in a second. So the tiles, we're going to do tiles I. So if you can imagine that we're going to output an image. Let's see here. So actually, what I'm going to do, I'm going to go ahead. I'll create a little kind of diagram here for you. So you can imagine you have tiles 0 equals okay, so you say tiles 0 equals 1, tiles 1 equals 1, tiles 2 equals, let's say that 1 equals to 0, whatever, tiles 3 equals 3, tiles 4 equals 4, that's 5, and that equals 1. So this is just arbitrary. You can set this to whatever you want because it's like a map. So it's like you can set the values to whatever you want, and then that'll go on and on. There'll be different values in each one of these places in the list, which corresponds to which kind of tile that you want. So basically, what it's going to do is this is just an index. These are just indexes. What you're storing in here into the map tile palette list. So basically, the point of doing that is that you only load, it takes a good amount of memory to load these images, so you only want to load them once inside of here, and then you can just output them. You can just display them on the screen over and over again in different places. It doesn't really matter that it's the same image. There's certain things that you can do inside of processing that it will matter if it's the same image, but in the way that we're using it here, it doesn't matter. You can just reuse the images over and over again. That way you can save memory. It saves time and everything. It's just the most optimal way to do it. So that's why we're doing it this way, instead of loading an actual image into each each item in this list of tiles. It's just, instead it just stores integers, which are just indexes into the map tile palette list over here. So you're just saying, like, at each place in the map, I want this map tile, I want this tile from the palette, and then, so each place in the map, I want this tile from the palette, I want tile number 1 from the palette, and I want tile number 0 from the palette, I want tile number 3 from the palette, tile number 4 from the palette, blah blah blah, whatever. It's arbitrary because it's a map. You can create whatever you want, whatever kind of map that you want. So anyways, so this is where we got to do a little bit of math to figure out. Again, this is it's just a one-dimensional list, but we're actually going to output a two-dimensional map, and then the size of the map is 50 by 50. So we got to do a little bit of math here. I'm going to actually just look up what I did in the old code. Okay, all right. So this is what we got to do. So basically, one thing I forgot to mention here was that the size of the tiles will come into play here, because you got to imagine, like, you have to know the size of the tiles so that you can display them next to each other. So I'm going to create these two more variables here: tile width and tile height, and the tile width is going to be equal to 32, and the tile height is going to be equal to 32. Now this is just because I got this from these tiles here. You can see, actually, if you look. Okay, so you can see here the image size is 32 pixels by 32 pixels. So that's where I'm getting these numbers from, 32 by 32. Each one of the tiles is the same size, 32 by 32 pixels. So that's the width of the tile, the height of the tile, for each tile. So we'll need that in the computation to figure out where to actually display the tile. So basically what we need to do is map this I value onto like an X and Y coordinates. So basically what we're going to do is that it's going to start at the upper left hand corner of the screen, and it's going to display the first tile at 0 0, and then it's going to go and display one tile to the right, one tile to the right, tile to the right, tile to the right. So it's going to keep displaying tiles until it displays 50 on the x-axis, and then it's going to skip down one row, and then it's going to display 50 again, and then skip down one row, display 50 again. That's how it's going to display. There's other ways that you can organize this, but this is the way that I've chose to organize this map. So the equation that we're going to use is going to be I, the value I, which is here, which is increments from 0 to whatever this is, size x times size y. So I, and that's going to be mod the size x times the tile width. So just to make sure the order of operations goes the way I want it to, I'm going to put that in parentheses. So I think that's correct. Let me just check against this real quick. Yep. And then what we want to do is, here, I'll actually put this over here so you can see it more easily. And then the y is going to be, I believe it's a little bit more complicated. Let me just check here. Yep, so it's going to be I divided by the size in the x direction times the tile height. So being that we're working with integers here, this is integers, I can do this divided by operation, also the modulus operation, which will basically not give me any decimal point numbers. This will either be an integer or it'll be 0 if it comes out to be less than integer. So you can imagine from I equals 0 all the way up until I equals 49, the I divided by the size x, this is going to be the I divided by 50, is going to be a number that's less than 0. So this is going to actually return 0 since it's an integer. These are both integer numbers. It's going to be an integer operation. It can't represent anything that's has any decimals past the decimal point. So any decimals, any number lower than 1 and greater than 0 is going to be just automatically just turn into a 0, being that this is an integer operation. So you can imagine that, you know, until it gets past the first row, that's going to be 0, and it's going to be times tile height, so that's 0 times whatever is equal to 0. So this is going to display at y equals 0. So these are basically what I'm doing is the image function here takes the image that you want to display, and then it takes the x coordinate and the y coordinate that you want to display it at. So this is going to be 0 until I is equal to 50, and then once it's equal to 50, then this is going to return, this right here is going to return 1, and until it gets up to 100, which is 50 times 2, then it's going to be 1, because again, as I said, these are integer numbers, so it can't display anything past the decimal place. So it's going to be 1 times the tile height, which is 32. So basically you can imagine it's going to display at 0, and then it's going to pop down 32, and then start displaying the next row of tiles, and then it's going to keep doing that on and on. It's pop down, 32 times 2, which would be 64, display that row, then 32 times 3, then 32 times 4. So that basically it'll let it display all the tiles along one row, 50 tiles along one row, and then it'll pop down the next row, 50 tiles pop down the next row. And then this is the modulus operator, which it returns the remainder from the integer division of this. So again, we said there's going to be equal to 0 whenever the integer division will be equal to 0 during the being that while I is less than 50, and basically what this ends up is it takes the number I and it subtracts the what it'll return is I minus the integer division result, which will be 0 for I less than 50. So it'll be it'll basically return 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever is the value of I minus the integer division, like this right here, which would be 0 until I equals 50, and then once I equals 50 and once I is greater than 50, then it'll basically reset back to 0 and then return 1, 2, 3, 4, 5, 6, 7, 8, 9, until it gets up to 50 again. And so that's how the modulus works. Is it'll count up until you hit a number that's divisible with whatever this is right here, and that's going to be multiplied times the tile width. So you have 1 times tile width 32, 2 times tile width 64, 3 times tile width. So basically it just starts at 0 and then it pops 32, 32, 32, 32, 32, so it displays each one of these tiles. That's basically how it's going to do it. So I'm going to go ahead and save this, and then I'm going to go ahead and what I want to do, well actually let me just hit run just to make sure this actually, okay, so it didn't do anything yet because I'm not actually destroying anything inside of the draw function. I did, say display here, but this it's not getting invoked anywhere. This is just basically like a blueprint for how a map could work. I need to actually create a map now. So the way I do that is I say map. So basically, like I created my own data type. So map, and I'll just call it map lowercase. There is, Java makes a distinguishes between the case of the letters. So uppercase M map is different from lowercase m map. Anyways, that's what I'm going to call it, map. That's my actual, what's called the object that I created based on this class, which is like a blueprint. This is the blueprint I used to create this object. So then map this actually, well, I'm sorry, this created a reference to a map object up here, and then to actually create the map object, you do new map, and then it doesn't need any parameters input because it's using this what's called a constructor function right here to construct the object, and the way it constructs it is it just does all this stuff inside of here. So that created a new map, and now what I want to do is I'll actually draw the map. So what you want to do is map.display, and again, that one does not take any parameters here, as you see. This is how you call it, display. So map.display, it's saying call the display method for this map object. That's what it's saying. And I'll hit save. And basically, one of the things about Java is that when you create a new array of integers, I'm not specifying this anywhere, but Java just by default will set it to all zeros. And if you remember, 0 is it's the index inside of this palette that corresponds to the grass tile. So what we should expect to see is just it fills up the screen with grass tiles. So let's see what happens here. Go ahead and run. Boom. So that's what you get. All grass tiles, all displayed evenly next to each other. So that is, I think that's going to be the end of this first tutorial here. I'll create the next tutorial so you can get further into, but that's just the basic map display, how you actually display tiles next to each other. These equations here are really probably the most important thing to take out of this here, is just how you display it using this kind of mathematics, and create a very simple list like this. So this is like an optimized way to store a map and a way to display the map. So that's it. Thanks a lot. Again, check out my Patreon if you can. You can download the game. You can get all those tiles that I used, and you can also copy the code straight out of this if you want to. This code is much more complicated, obviously, inside of this finished product here, but you can also play the game. And that's everything. Thanks a lot. Have a nice one. Peace.